video, we are going to talk about the radian measure of the angles. In class, we have already discussed that what is a standard position of the angle. So remember that standard position means vertex has to be at the origin. This is called initial side and this is called terminal side. If the angle goes into counterclockwise, it's considered positive angle. If it goes clockwise, it's a negative angle. One more time, counterclockwise is a positive, clockwise is a negative angle. So then there is a word coterminal angle. Coterminal angle means positive angle and negative angle theta. They share the same terminal ray, that is called coterminal. So this number, let's say 120, and then this is a negative angle. So they both are coterminal angle. Coterminal means they have the same terminal side. Now measuring angles. We will measure angles throughout this course and future courses in a different way, which is we will always use radians. We will never use degrees. In class, I already explained that why we don't use degrees, because degrees are not real numbers. Radian is a real number. And because of the domain and range issues, we do not use degrees. We always use radian. So what is 1 radian? 1 radian is a ratio of this arc length divided by a radius is a radian. Radian is a ratio. Ratios do not have any units, which means we measure the angles without units. And how is that possible? Well, because this is a ratio, which is arc length over radius. So if it is a centimeter over centimeter, centimeter get cancelled and you get the radian. So let's talk about how many radians are in one circle. So circumference is a arc length for the entire circle. Think of that way. So arc length of the entire circle, and if I divide by a radius, I get the 2 pi, which means one complete cycle of the circle is equal to 2 pi radians. Be careful, radius is a length, radian is a angle. For understanding purpose, we are saying 360 degrees, but we are not going to use degrees. We will just understanding purpose, but we do not use degrees for any trig ratios. So let's take a look at a couple of examples here. In this part, this says, let's read carefully. Remember AP calculus, AP pre-calculus is all about lots of words. So consider the angle theta created by a quarter circle of radius 4. Find the major angle of theta. So which means I need a ratio of arc length. What is this quarter circle of the arc length? Now the entire circle, remember the entire circle, arc length is a circumference, which is a 2 pi r. And if I divide by 4, so this is a arc length of this quarter circle. And the radius is also 4. So if I divide by 4, which is a here, arc length, which is a 2 pi. And if I divide by a 4, I get pi over 2. So the curious question is, why we are doing so much work? We know that the whole circle is a 2 pi and a quarter of the circle is a half of half of half, which is pi over 2. So is it different if the radius is different? No. If the circle is a tiny circle or a large circle or any length, quarter circle always will have a pi over 2 radian. No matter what the size of the circle, quarter circle will always have. And think about that also, it's a 90 degrees. No matter what the circle is, you go from east to north, always angle is pi over 2, which is 90 degrees. So irrespective of the size of the circle. Now let's look at another example here. Find the measure of the angle formed by third of a circle. Radius is a 3. At the origin in the clockwise directions. They want us to find the angle with a clockwise direction. So is it a different angle? Yes, you should know that positive angles are counterclockwise, negative angles are clockwise. Okay, so if you don't want to do so much work, then the whole circle is a 2 pi, and a third of a circle is a 2 pi over 3. And remember, we discussed that the radius could be anything. It's a third of a circle is a third of a circle. Question is it counterclockwise or clockwise? So if I'm going clockwise, then it is negative 2 pi over 3. And if you are using again the ratio, arc length is a, remember the whole circle is a 2 pi r, which is arc length of a circle. If I'm cutting by third, that means divide by 3, and the radius is also 3. So that becomes 2 pi over 3. The difference is negative because we are going clockwise. Okay, so now what is a unit circle? Unit circle is a circle with a radius 1. In trigonometry, you will always see the circle centered at the origin because we always measure the angle with a vertex at the origin. So, equation of the circle is x square plus y square equal to r square, and you can say that radius is a 1. Now, coordinates of all those points are very important because you should know that radius is a 1. That means this point is 1 and 0. This point is a 0 and 1 because this is always x. That's a y. Negative x, y. X is a 0, y is negative 1. So have a clear understanding that on x-axis, y is always 0, and on y-axis, x is always 0. So unit circle radian measure is the same as the length of the arc length formed by the angle. We are going to look at the trig values. But before we jump onto the trig values, we must have a very clear idea about the angles measured in in radian. Okay, so let's practice with a few angles in radian. Sketch the picture of the arc length described by the here and based on the unit circle. Then find the measure of the angle corresponding to the given arc. 1/6 of a circle. So we know that the circle is 2 pi. 1/6 is pi over 3. Easy peasy. But remember, counterclockwise. Counterclockwise, that means it is positive pi over 3. That means this is your pi over 3 angle. Now, why I divided this into 6 is because you are making a whole circle and you are making 6 parts. So informally, I'm going to already explain what pi over 3 is a very special angle, 60 degrees, and you have to have a clear idea that this is 0, this is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, back to 6 pi over 3. But we are going to look at that into more details in a couple of minutes. So 2 full revolutions of the clockwise direction. Remember, clockwise means negative angle. So 2 times 2 pi, but that will clockwise will make it negative 4 pi, which is 2 full rounds, but you go backward and then back to the same place. Okay, so description. 3/4 of a circle counterclockwise. 3/4 of a circle, which means 3/4 times 2 pi. But then counterclockwise means positive angle. So 3/4 times 2 pi is 3 pi over 2. You have to have a clear idea. 3 pi over 2 means it's located in south. And that is a 3 pi over 2. Now this is the same as negative pi over 2. It is the same as negative pi over 2 if I go clockwise. Okay, so one more. 7/8 of a circle counterclockwise. 7/8 times 2 pi, which is 7 pi over 4. And 7 pi over 4 clockwise, which means you start from 0 and you end here. 7 pi over 4 is a very similar to negative pi over 4. They both are called coterminal angles. If you go clockwise or counterclockwise, you come at the same point. They are called these two are called coterminal angles. So let's take a look at some more. Take a look at the whole circle. Now we are looking at the entire circle here, and this question says the circle above has markings at the important angles that will be used repeatedly means forever for entire unit 3, which means in a we keep going all the way, and all the time when we come backward, forward, all the time we use these angles. We call them special angles. Special angles means they have a special meaning, special location, and these are all special angles. Now it says first quadrants are already given to you. Use these angles and symmetries to complete the remaining angles. Many times students are really struggling to memorize these angles, and I'm going to say that this entire unit circle you can dissect into 4 layers. One layer is called quadrantal, which is a 90-degree layers of, I'm sorry, pi over 2 layer, which is 0, pi over 2, pi, 3 pi over 2, back to 2 pi. Now, this is a layer number 1. Then we have a 3 different layers. Another layer is called pi over 6 layer. And these are the angles you consider pi over 6. Another layer is called pi over 4 layer. And I will explain how to count those. And the third layer is pi over 3 layers. So let's talk about what are those numbers. Pi over 4 layers. So you start making 4 parts. Pi is here. 4 parts, and start counting 1 pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, 6, 7, 8. So these are all 45-degree angles pi over 4, and they are all very symmetrical, and you go always count counterclockwise for positive, clockwise for negative. So this is a pi over 4 layer. Now let's take a look at pi over 3 layers. Pi over 3, that means pi is here on the 3 pi over 3 is a pi, and you make 3 parts. So 1 pi over 3, 2 pi over 3, 3, 4, 5, 6. 6 pi over 3 is the same as 2 pi, back to 0. So if you are looking at the pizza slices, you are making 8 slices of pizza, you are making 6 slices of pizza. Now the one more is called pi over 6 unit layer, which is 6 pi over 6, and you make 6 rounds, and you can say that that is a 1 pi over 6, 2 pi over 6. Remember, 3 pi over 6 is the same as pi over 2. 2 pi over 6 is the same as pi over 3. So in fact, pi over 6 layer has both of these hidden inside. I mean, not pi over 4, but pi over 2 and pi over 3 are all inside. So you have to have a really, really good idea about the location. Ideally, this is the east, this is the west. One less, one more. 5 pi over 6 is one less, 7 pi over 6 is one more. Once you understand these fractions and the locations, you will not have to use, you will never be getting anything wrong. So let's talk about the angles. Sine, cosine, tangent of a unit circle angles. Until now, we know that the y was sine theta was y over r. Now we say that the radius is a 1, so it's a simply y. Cosine was x over r, and we say that radius is a 1, so simply x, which means your x and y coordinates are simply cosine and sine values. Tangent theta is the same as y over x, which is same as sine over cosine, which is the same as the slope. Remember, we defined tangent as a slope, which is a rise over run. So unit circle made everything so much easier, because now we can say that the x coordinate represent cosine theta value and y coordinate represent sine theta value. So for example, this is a pi over 3 triangle. Why do I know it is pi over 3? Because I can say that the cosine value is 1/2, sine value is a root 3 over 2. So if I go back to geometry, we can say that this is a right triangle, and you may have seen this triangle as a 1, 2, root 3, which is perfectly all right. They both are same. The difference is we want to put this triangle into unit circle, and we had to make hypotenuse 1. So if you divide everything by 2 here to make it 1, then they both are same. Which one you are supposed to know? Both of them. Have a really good idea that cosine theta is 1/2. That means angle is pi over 3. 60 degrees for our understanding, but we do not use 60. We just say pi over 3. So this is a pi over 3 triangle. If you have to evaluate the values, let's take a look at here. You are given some information. P is 1/2 and root 3 over 2. I mean, informally, I already explained that sine is a y coordinate. So you clearly see the y coordinate. That is your y value. This is sine, this is cosine. And what is a tangent? Well, tangent is the ratio of these two. So know that the fraction over fraction means complex fraction. You have to simplify. So you keep this, you flip this, 2 get cancelled, root 3. Okay, so let's make a connection. This is very important information. Tangent theta is a root 3, which means slope of this line is a root 3. Slope is a root 3, which tells you that this is a steeper line because root 3 is bigger than 1, and that means the angle is a bigger angle. So anytime you are working backward, you can make a connection that slope is root 3. That means it's a bigger angle. In second example says point R is reflected over the y-axis. So let's talk about this. Reflection over the y-axis, which means x becomes negative, y becomes positive. So then what is a cosine? Sine theta, cosine theta? Well, it's still same. The difference is cosine is negative. And guess what? The tangent is also negative because now it is a slope with a negative line. You can see that's a negative slope. So then what will be this angle? You have to make connection that if you reflect that pi over 3 angle into second quadrant, that becomes 2 pi over 3. Uh, you should begin work on the homework, which is all the way page number 17 and onwards. Thank you so much.